metals lose, non-metals gain. Transfer of electrons, the valence is changed. Positive cations, negative anions, oppositely charged, held in the reins. A strong electrostatic attraction in every single direction. It's a giant ionic lattice, a regular repeating frame, high melting points to break the bond, thermal energy to overcome the strain. Strong forces hold the structure tight, electrostatic power within the side. Solid crystals do not conduct, the ions are fixed in a silent pact, but melt with heat or dissolve in the flow. The lattice breaks, the ions can go. Mobile charges carrying the current in the liquid state. The movement is fluent, brittle walls that snap and slide when like charges meet and collide. Repulsive forces push the layers away. A shattered crystal falls to decay. Giant lattice, strong attraction. Lattice fixed, then free.
Two non-metals approach the line, a shared pair of electrons to entwine. Nuclei attracted to the negative space, a covalent bond fixed in place. Strong, intramolecular, and tough. But for the bulk, it is not enough. Simple molecules H2O, CO2 weaken to molecular forces between the few. Low melting points to overcome the pull. No mobile ions, the shell is full. Insulators in the liquid and the solid state. The molecules drift at a low rate. Giant structures, the lattice expands. Carbon atoms and diamond take hands. 4 strong covalent bonds per cell. A tetrahedral rigid shell. Extremely hard, high melting point. No free electrons in the crystal joint. Graphite layers in hexagonal rings. 3 bonds per carbon the structure brings. 1 delocalized electron per atom is free to carry the charge for all to see. Weak forces let the layers slide. A lubricant where the planes collide. Shared pairs, diamond 4, graphite 3. The covalent web is defined. positive ions in a regular row, a sea of electrons in a constant flow.
Delocalized, detached and free, a giant metallic geometry.
Outer shells lost to the cloud, a unified structure silent and proud.
Strong electrostatic attraction
Between the ions and the electron fraction.
High melting points to break the hold.
In the silver, the copper, the iron, the gold.
Conducting the heat and the current too.
The electrons drift all the way through. Layers of ions can slide and shift.
Under a force they glide and drift.
Malleable, shaped by the hand.
Ductile, drawn into a wire strand.
The sea remains to hold the bond, a flexible link
and a bridge beyond. Pure metals, soft in their state. Regular size is the side their fate. But add an atom of a different size, an alloy is born where the strength lies. Distorting the layers, locking the slide. Hardness increases with nowhere to hide.
sea of electrons,
Delocalized
malleable,
alloy.
the flow is constant.
Scaled down to the nano domain. 1 to 100 nanometers remain. As particles shrink, the surface expands. A massive area for chemical hands. High surface to volume ratio found. New properties start to abound. Silver is toxic to bacteria's breath. Self-cleaning glass and the catalyst's depth. Nanoparticles different from the bulk. Different colors from the macro hulk. Titanium dioxide in a transparent veil, blocking UV where the large oxides fade. Small enough to pass through the skin. We monitor the risks from within. Smart materials sense and respond to a stimulus, they form a bond. Photochromic intensity of light darkens the lens, then returns to bright. Thermochromic shift in the heat. The molecular structure is never discrete. It changes its color, it changes its state. A reversible path decided by fate. Shape memory alloys like nitinol stand, deformed by a force or a stretch of the hand, but provide the heat to the lattice again. It returns to the shape it held in the main. Hydrogels trapping 1,000-fold weight in water. They swell to a polymer state. 1 to 100, surface to volume. Stimulus
to 14. The power of H. Acids releasing the H plus ion. Below the 7, the numbers descend. Alkylus releasing hydroxide OH minus. Above the 7, the alkalinity grows. Neutral at 7, where the water flows. Acid plus base, a salt and water. H plus plus, OH minus, H2O the daughter, a neutral state. An exothermic fate. Hydrochloric becomes a chloride, sulfuric becomes a sulfate, nitric becomes a nitrate. The metal replaces the hydrogen start, naming the salt is a chemical art. Acid plus metal, a salt plus hydrogen. Acid plus carbonate, salt, water, CO2. Effervescence, the fizz in the glass. The protons, the ions continue to pass. Strong acids, fully ionized. Weak acids, partially. Equilibrium lies. Concentration, the amount in the space. Strength, the degree of the ion chase. 0 to 14. H plus, OH minus. Salt and water. The pulse is constant.
To determine the unknown concentration of an acid or alkali, we use a titration to find the exact volume needed for neutralization. Use a pipette to measure a fixed volume of the base into a conical flask. Add a few drops of indicator, phenolphthalein or methyl orange, to see the change. Fill the burette with the acid, noting the initial volume at the meniscus level.
Slowly add the acid from the burette while swirling the flask continuously. As the end point approaches, add the acid drop by drop until the color shifts. Record the final volume and subtract the initial to find the titer used. Repeat the process until you achieve concordant results within 0.1. Calculate the mean titer using only these consistent, accurate values.
The moles are the bridge between the known and the unknown.
Calculate the moles of the substance with the known concentration first.
Moles equal concentration multiplied by volume in decimeters cubed.
Use the balanced equation to find the molar ratio of the reactants.
Then divide the moles by the volume to find the unknown concentration. Concentration is moles divided by volume.
Volume must be converted from Cm cubed to dm cubed.
Divide by 1000 to make the conversion correct.
Phenolphthalein turns from pink to colorless in acid.
Methyl orange turns from yellow to red as the pH drops. N equals C times V.
Concordant results.
The endpoint is reached.
The bridge is crossed. Raw materials from the top. Iron ore, coke, and limestone. Hot air blasts from the base. Oxygen meets the carbon start. Thermal energy begins to heart. CO2 is born in the heat. Carbon dioxide meets the coke. Carbon monoxide is the agent spoke. It strips the oxygen from the ore. Molten iron sinks to the floor. Reduction happens in the stack. The chemical cycle, never looking back. Limestone added to the flow. Thermal decomposition starts to grow. Calcium oxide and CO2. Oxide needs silica to see it through. Slag is formed, a liquid shield floating on top of the iron yield. Reduction is the loss of O. Carbon is higher in the series globe, but for aluminium, carbon is weak. Electrolysis is the path we seek. Stronger bonds require the spark to pull the metal from the dark. Hematite, the ore of the red. Coke, the fuel that must be fed. Slag and iron tapped at the base. Different densities find their place. Reduction. Slag and iron. The furnace is breathing. The pulse is constant. Aluminium in the earth. Bauxite, the ore of its birth. Purified to alumina white. Aluminum oxide held so tight. Too reactive for the carbon stack. Electricity to pull it back.
temperature goes, lowering the melting point of the cell to save the energy we know so well. Graphite anodes dipped in the melt. The power of the circuit is felt. Aluminium ions, Al3+ cations migrate to the cathode free, gaining 3 electrons at the wall. Reduction happens to the ions, all molten metal sinks to the base, tapped from the cell at a steady pace. Oxygen ions, O2-, anions migrate to the anode. They're losing 2 electrons at the rod. Oxidation happens in the quad. Oxygen reacts with the carbon pole, burning the anode is the chemical toll. Anodes must be replaced. Carbon dioxide is the gas we trace. Economic cost of the power used. Recycling is the path to be chosen. Cryolite, anode, cathode, Al3+ O2-. The circuit is closed.
Energy is never lost, only transferred at a cost. Exothermic reactions flow, releasing heat to the surroundings glow. The temperature rises in the glass.
The energy of the system starts to pass.
Exo
Out, endo in.
the balance of the bonds begin.
Breaking requires the energy spark,
Making releases the light from the dark.
Endothermic reactions take.
Absorbing heat for the bonds to break.
The temperature falls in the space.
Energy enters the chemical chase.
Thermal energy drawn from the air.
A cooling sensation is gathered there.
Activation energy EA.
The minimum needed to start the way.
The peak of the hill on the profile chart.
Before the reactions can truly start.
Exo drops to a lower state. Endo climbs
to a higher fate. Self-heating cans and combustion fire.
Exothermic energy rising higher.
Sports cold packs and photosynthesis light.
Endothermic energy
Holding tight.
exo out.
Endo in.
The shift
Is constant.
For a reaction to take place,
Particles must collide in the space.
collision theory defines the state.
The frequency of collisions sets the rate.
But only those with the energy spark and correct orientation hit the mark.
The rate of change,
The frequency of successful hits,
where energy exceeds the activation threshold.
more successful collisions per unit of time,
Make the reaction start.
to climb.
Increase the concentration of the solution. More particles per unit of volume for the resolution.
The frequency of collision starts to rise,
Increasing the successful ones we prize.
for gases, the pressure does the same,
Crowding the particles into the game.
surface area of a solid mass,
A powder allows more particles to pass.
more sites exposed for the hits to land,
Increasing the frequency as we planned. Increase the temperature of the flow.
particles gain kinetic energy to go.
They move faster, but that's only part.
A greater proportion hits with the heart.
More particles exceed the activation wall.
The frequency of successful hits will call.
A catalyst provides the way.
Lower activation energy to pay,
An alternative pathway for the bond.
of which the particles are fond. More successful collisions now occur. The rate increases in a blur.
Successful collisions.
Per unit of time,
Activation energy.
the rate is constant.
Crude oil, a mixture from the deep. A complex fossil in its sleep. Hydrocarbons only C and H, separated by the boiling point. Fractional distillation is the way to find the uses of the day. The column is hot at the base, cooler at the top of the space. Vapors rise and they condense. At the boiling points, the fractions commence. Short chains rise to the peak. Long chains stay at the base we keep. Demand is high for the short and light, fueling the world with their burning alkanase, the saturated frame. Single C to C bonds we name. Every carbon is bonded tight to as many hydrogens as is right. The general formula we trace: CnH2n2 in the space, methane, ethane, propane 2. Butane follows the sequence through. Alkanes, the unsaturated pair. A double carbon bond is there. CnH2n is the rule. Reactive molecules for a chemical tool. Ethane to ethene we see. Propene follows the carbon 3. Bromine water is the test we show. Orange to colorless as the double bonds go. Viscosity increases with the length. Intermolecular forces gain their strength. Flammability drops as the chains grow. Volatiles evaporate with a faster flow. The boiling point begins to rise as the carbon count takes the prize. Saturated, unsaturated. Bromine goes clear. The chain is constant.
A new homologous series we find, with the same functional group in mind.
The alcohols, the hydroxyl change.
The OH group within the range.
The general formula we trace:
CnH2n plus 1 OH in the space.
Methanol with carbon 1.
3 OH, the count has begun.
Ethanol with carbon 2.
C2H5OH follows through.
Propanol for carbon 3.
C3H7OH for the world to see.
Butanol for carbon 4.
C4H9OH
finishes the door.
2 paths to the ethanol flow. One is fast and one is slow. One is pure and one is crude. The choice depends on the chemical mood.
From the crops a renewable start.
Glucose breaks
With a biological heart.
Yeast at 30
To 40 degrees.
anaerobic conditions, if you please.
It's a batch process.
Slow and low,
Distillation is needed for the purity to grow.
low energy and carbon neutral aim.
A sustainable way to play the game.
From crude oil, ethane is found. Hydration with steam on industrial ground.
Phosphoric acid catalyst is key.
High pressure and heat for the yield we see.
A continuous flow,
Pure and fast, but non-renewable, it cannot last. Fermentation is the green slow breath. Hydration is the fast fossil death.
one for the planet, one for the speed, meeting the global
Ethanol need. phosphoric acid, renewable,
the essence
is balanced. Oxidation, the burning fire, releasing energy, rising higher. Complete combustion in the air, plentiful oxygen is gathered there. Carbon to dioxide flows, hydrogen to water vapor goes. Blue flame, energy released, the chemical potential has ceased. CO2 and H2O, the only products that we know. Bioethanol, the greener choice, carbon neutral in its voice. CO2 absorbed as the crops grow, matches the CO2 released in the flow. But land is taken from the food we need to plant the fuel instead of the seed. Destruction of habitats to make the space a complex balance for the human race. Incomplete, the oxygen is low, a yellow flame begins to show. Carbon monoxide is the breath, a silent gas that leads to death. Particulates of soot and grime, marking the air throughout time. Sulfur, impurities in the fuel. Sulfur dioxide is the rule, rising to the clouds above. Acid rain is what they move. Nitrogen oxides from the heat. Internal combustion in the street. The greenhouse effect starts to build with CO2. The atmosphere is filled, trapping the heat within the sphere, changing the climate year by year. Global warming is the cost of the energy that we have lost. Combustion complete, incomplete. The pulse is still.